Hi, welcome again. In this short course, we are going to learn about basics of vector mathematics and we're going to relate that into Unreal Engine. First, we're going to talk about vector direction and the vector length. Basically, vector has a length and a direction component. We're going to learn about that. After that, we are trying to scale a vector, and then we are trying to add a vector, and also we're trying to subtract a vector. While we are doing all these things, we are going to think about the actual meaning of that in the sense of Unreal Engine and also in the sense of geometry in general. After that, we're going to do a short project. Basically, it will look something like this. Right here, we have two balls, and the first one is some sort of arrow. You can see here we have a pointer. I can select one ball and I can move it any place I like. And also I can move this other ball as well. So as you can see, all the time the blue arrow object is pointing towards to this orange ball. Then I have a button in the details panel called shoot. I can click that. You can see it will gradually comes to this ball. I can change the position again of any of these things. Right. Okay. Then I can hit the shoot again and it will find the location of the ball, and it will gradually goes towards that ball. As you can see, we are working with some example based projects. So check the description below to download the example apps so we can work together. Alright, let's get started. In this lesson, we are looking at vector direction. So let me show you a little demo. Here we are open the first level on the completed directory. Then I'm going to simulate this level by clicking here and hitting this simulate button. Then I'm going to select this orange ball and I can move here and there. And you can see this point over here is looking at this ball. So it doesn't matter where I put my ball. So it will always follow that direction. So basically here what I want to show you is this ball has a directional path. So that's how this arrow or the point can point towards this ball. So let me show you how to do this. It's quite easy. Now we are trying to understand how this works. First, there's a practice level for this lesson. So we're going to start this. Then go to the content directory. We have practice directory. Inside levels, we have this vector direction directory. Go into that and then open this level. So now I can simulate here. Then I can move this ball and it doesn't happen because we haven't added the functionality. Now I'm trying to add that functionality. And there are a couple of things we need to note. Here we call this arrow, even though it's not arrow. And here we have a target variable, target parameter. So here we select this BP ball. You can see this ball actor as a target for this arrow. So basically inside this arrow, we can get the location of this ball. Right, let's go into this blueprint. I can click this edit BP arrow button. So now I'm inside the blueprint. Here I'm going to open the event graph. And then here we have a tick event. So basically we try to see whether the target is a valid object, and then we proceed if that's the case. So now I'm trying to do is pretty simple thing. Here we have this target which I get from here. Then I'm gonna drag this and search for get actor location. Right. And then I'm gonna grab the return value again and search for normalize. Right. So here we normalize this vector. And if you don't know what normalize is, just don't worry. This is something you have to do. And then this is the direction of this vector. So basically every vector has a directional component and a magnitude component. Here we are looking at the directional component. All right. And then we set the direction to the set text. So basically we can see that vector on this caption. And then I'm going to add a new node after the set text called set actor rotation. Right. So basically we will rotate this actor, this arrow pointing towards to this direction. Then I simply grab the return value and connect it to this new rotation. Then it will create a new node here. Just don't worry about for right now. We will talk about this later in the course. Right. And then I'm going to compile, save, and let's try to go to the map, simulate. Okay, let's see whether this works or not. See, now you can see it really works. What we did is very simple. This orange ball has a position. It's positioned as a vector because we have three numbers, three axes, x, y, and z. That vector has a directional component. So we get that and we use that direction to rotate this arrow. So that's what we did, and so this is quite satisfying. Right now you know how to do this. Try to open this level on your example lab and try to do exactly the same thing. Alright, in this lesson we are looking at the vector length. Here we have our usual arrow object and the ball object, and let's try to simulate this and see what we can do. I hit the play icon, I enable the simulate option, then I can grab this ball, I can move it here and there, then I get a number on the screen. Then I can drag it on the x-axis. You can see it getting smaller and smaller when I close to this arrow object. Basically it shows the shortest distance from this arrow object to the ball in centimeters units. And this number is also known as vector magnitude, vector length, or maybe vector size as well. So keep in mind all these things point to the same thing. Alright, let's see how we can get this number and also how to calculate using very simple mathematics. Now go to your content directory, open the practice lesson, levels, and here we have the vector length level. Open that. Right, then I simulate again. Then I can move the ball, but this number doesn't change because we haven't had that functionality. So let's do that. So I'm going to stop this simulation and select the ball, and from here I'm going to hit edit ball. Then I load the event graph by clicking the event tick. Now here we already have a function which sets this text. Currently it's just a simple value 0. So here's how to get the vector length. Right click and search for get actor location. Drag this return value and search for vector length. Right, here you have the vector length inside the math vector section. So simply add that to your toText, this one, and I'm going to hit compile and save. Now when I simulate the game again, you can see now we get the vector length. Alright, it's simple as that. Now let's try to calculate this using simple mathematics. So I'm going to delete this vector length node, and if you're using a production game, you should definitely use this node, but this is just to demonstrate you how to calculate this value. Right, I'm going to delete this, then I'm going to right click on this return value and hit split struct pin. Then I'm going to multiply this value plot to plot using the same value. So basically I square this value, and I'm going to do that for y and z axis as well. Then I'm going to add all these three numbers together, plus, okay, add pin, connect this one. Then we have the sum of all these values. Then I'll get the square root of this value, sqrt, and this is the vector length. Right, you can see we get the same number as before. If you're curious how I get this value, so here we are using the Pythagoras theorem to get the vector length value. Actually, it's not that important how we get that value. It's important what this value does. Since this vector is the position of this ball, so we get the vector from this origin to this position. So this value gives us the shortest distance from this origin, the arrow object, to the ball. And that's what's important, and that's what we need to think about. Alright, try to do this by yourself and see how it works. In this lesson, we are looking at the unit vector. So basically, if I change this ball, you can see then my arrow is pointing towards this direction. So we earlier learned about this is as a directional vector, or the vector's direction. Actually, that's a unit vector. So basically, that's a vector with a unit 1 length. So in Unreal Engine, a unit is 1 centimeter. So this vector is always 1 centimeter long. You can see no matter where I put this, it always has a 1 centimeter as the length. Earlier we used a normalized method to calculate this unit vector or the direction vector. Now I'm going to show you how to calculate that using a very simple mathematics. Alright, let's get started. Now go to the practice directory, levels, and there's a directory called unit vector, and open the map. Now let's simulate this map. So as I move this ball, nothing happens. The reason is we haven't added the functionality yet. So here's how to create the unit vector. I'm going to open this arrow. I can click this BP arrow link. Alright. And go to the event graph, event tick. I already have some functionality to basically add the text to this caption. Now I'm gonna get the target. So here target is the BP ball. We get this target as a variable from here. Then I'm gonna get the target. I'm gonna type get actor location. Right, now we have a vector here. Then I'm gonna get the vector length. And then I'm gonna divide this vector by this vector length. Get this vector, divide, okay, by this vector length. Now we will get another vector which always has a length of 1. Then we have a set actor rotation node here. I'm gonna simply connect that into that new rotation value. So we will get the rotation from X vector. So I'll talk about this in a later video. We can double check by getting a vector length from here as well. And it should be always 1. Right, compile, save, and let's simulate the level. Right, so it's pointing towards the ball, and so that's the direction, and we get the length of 1 always. So try this by yourself. In this lesson we are trying to do vector scaling. So let's simulate this level. We have 2 balls over here, and let's start with the orange one. Here we have default position, default location, which is on the x-axis on 200 units, right? Then I can uniformly scale it, let's say scale to 2 times. Now we are here, so it's just expected. We scale it twice. Likewise, we can change the position as we like, and we can scale it twice, 4 times, you name it, right? So that's uniform scaling. As well as we can scale on the individual axis level. For example, let's say in this case we like to change it on the x-axis only, so you have the control on that, or y-axis, or combination of both. And sometimes we have to do that, and we'll talk about that in later videos. And the other form of scaling is the directional scaling. So that's we are doing with this green ball. Here we have directional vector, so I can change the direction over here, and then I can define a length to scale. And this is very useful. So for example, you have a direction like this, and then you need to go in this direction, for example 800 units or 800 centimeters. So here's how to do that. I want to mention it again. When it comes to games, directional vector scaling is one of the most useful thing to do. All right, let's see how we can do that. All right, go to the practice directory and open levels, and here we have the 4th level, and there's a level called vector scaling. Just open that. Now let's simulate this level. So I can change the orange ball, and it has exactly the same functionality we already had on the completed level. But about this green ball, we don't have anything, so we need to implement that scaling logic inside this green ball. So now let's have a look at this orange ball, how it's doing the scaling, so then we can get an idea of how we can implement this directional scaling on this green ball. I'm going to select this orange ball, and I'm going to hit edit BP ball. Here on the event tick, we don't have anything useful. We simply get the vector length, and that's it. And here we implement all the logic on the construction script. That's because we are trying to change all these parameters on the details panel. When you change something on the details panel, it will simply rerun the construction script. So this is an ideal place to do that. Depending on your requirement, where do you want to implement this could be different. Right, here's the logic. Extremely simple. We get the default location, and then we scale that using the uniform scale as a float. And then after that, we get the vector again, and then we try to scale that using the 3D scale over here. And then we get the final result, and then we assign that to the set actor location. Right, this is completely straightforward. In this case, we are trying to do a directional scale. All right, let's open this blueprint. Right, I'm going to open the construction script. Okay, now we have 2 variables, direction and the uniform scale. Then I'm going to grab this direction. Now I'm going to normalize this vector and get a unit vector or a directional vector out of this. And the reason is we are not sure this direction user input is always a unit vector. So this is something useful thing to do. Right, then we grab the uniform scale. All right, we simply multiply. And then we are going to grab this final vector, and then we assign that into set actor location. And then we connect that into the construction script, and that's it. So we can simulate this level. All right, I'm going to select this green ball. From here I can simply change, and yep, and it does exactly what we need. All right, now it's your time. Try to do this by yourself. In this lesson we are looking at vector addition. So now we are in the level 5 vector addition, and let me simulate this level. All right, here we have 3 balls, and this green ball's position is the combination of these 2 orange balls. For example, on this orange ball, let me change the y-axis to 600. Now you can see our green ball's y-axis is 600. At the same time, I can change these other orange balls x-axis to, let's say, 800. So green ball is also having 800 on the x-axis. So basically, from the mathematical level, you can see addition mean we adding the individual component of the vector. Right now, let's think about this in a more practical way. So let me change the view a little bit. All right, now let's say I want this green ball to go x direction another 100 centimeters. So here's how to do that. So basically I need to add another 100 centimeters onto the existing vector. So basically we call as translation. For example, let's say I want to go somewhere over here. Okay, then all I have to do is, so I need to add a vector of, okay, something like this, something like this. So if we know the direction and the magnitude of the target vector, so we can simply add that value into the existing vector and we can translate into that position. Right now we don't know how to calculate that direction and the magnitude, but we're going to talk about that in the next lesson. Okay, now let's try to see how to add vectors in Unreal Engine. So here I'm inside the practice directory, levels, and the 5th level, vector addition, and let me open that level. And then if I simulate, so I can change these orange ball, nothing happens to this green ball. So because we haven't added that functionality. So let's implement that. Then I'm going to select this green ball on the level and hit edit BP added. In this blueprint, we have 2 variables with A and B. Then if I go to the world outline, let me select this BP added ball. And you can see A is the BP ball, the first orange one, and the B is the second orange one. Then I'm going to drag both A and B into the scene. Right, then I get the get actor location, and I'm going to do the same for B. Right, and now we have 2 positional vectors. So now I'm going to simply add them together like this, vector to vector. Right, now I have the added vector. Now I can simply do anything with that one. So for example, let's try to print that first. And now let's try to set this position into this blueprint. In order to do that, I can simply drag this yellow point and search for set actor location. All right, so now we have this. I'm going to simply connect that to here. All right, that's it. Then I can simply compile, save. Then I can simulate this level. Now I have the expected functionality. All right, now it's your time. In this lesson, we are looking at vector subtraction. Most importantly, we use vector subtraction to find displacement between 2 vectors. Now we have our usual arrow and the ball. All right, let's simulate this section. Now let's try to move the orange ball. So you can see now I can see the direction. This arrow is pointing in the direction as previously. As also we can see the vector length from this arrow to this ball. Right now this arrow is in the origin. If you look at carefully, here we have the vector's positional length from the origin, and here we can see the vector length from this arrow object to the ball. And then let me try to change the location of this arrow object. Now you can see I can change the location, and as soon as I change that one, vector length from this arrow object to the ball is changing, but the vector length of the original ball is the same because we haven't changed the location of the ball. I can change the arrow's position as anywhere like this. It will always find the location. Here we use vector subtraction to find out this displacement vector between 2 vectors. All right, now let's see how we can do this. Okay, now I'm inside the practice directory. Then I go to levels. Here we have the 6th level, and I'm going to open this vector subtraction level. Then I'm going to simulate this level. Now I can change the location of this ball, but nothing happens. On this arrow object, we have the target variable. We assign this ball into that variable, so we can access that ball's location or anything inside this arrow's blueprint. So I'm going to hit this edit BP arrow on the world outline. Then I'm going to open the event graph and the event tick function or the event. Here's how to do that. Extremely simple. Now I have the target actor, that's the ball. So I'm going to get actor location. Right. Now I'm going to subtract this vector by another vector. All right. Then I'm going to get the get actor location, current actor's location, which is the arrow's location. Now we are getting the displacement vector. So basically this order is very important. So here we get the direction from the second vector to the first one. You can see from the arrow to the ball. Right now we have the displacement vector. Let's split out the directional component and as well as the magnitude or the vector size or vector length. I'm going to grab this and I'm going to type normalize. Right now I have the direction. We already have the set actor rotation node here, so I can simply connect this normalized vector into this. So basically we are rotating this blueprint related to this direction. All right, now let's try to get the vector length, and then I'm going to connect that into this caption so I can see that on the screen. Okay, now let's compile, save. Let's go to the level. Right, I'm going to hit simulate. Okay, now we have the direction identified correctly. I can move here and there. Okay, and I can see the vector's length as well. Now let's try to change the location of the arrow object and new length from the arrow to the ball. All right, now it's your time. Try to implement this inside your practice level. In this lesson, we are trying to do a simple project based on the things we have learned so far. Okay, now we have our usual arrow and the ball, but here I can click on this arrow object and then I can go to the details panel and there's a button called shoot, and then I can click the button and this arrow is gradually goes towards this ball, and I can change the position again. So I'm gonna change the arrow's location into somewhere random. Okay, right, then I can change the ball's position also somewhere random. No matter where I put these objects, arrow is always pointing to this ball, and if I hit the shoot button, it will gradually hit the ball. So that's the project we are going to do right now. All right, go to your practice directory and we have levels, and we have a new level called project shoot'em. So this is the practical project. I load my level and then I can simulate, and there's a button called shoot, but when I click that, nothing happens because we haven't added that functionality yet. So let's start working on this functionality. All right, let me open this blueprint of this arrow. Right, then I load my event graph and there's a new custom event called shoot. That's why you can see this shoot button on the details panel. Okay, now we have the target object, the ball. Then let's get the actor's location, and then let's try to get the displacement vector to this ball or target, and then I get the get actor location of the current blueprint, and then I'm gonna subtract this target's position from our actor's position, and then we get a displacement vector from this arrow object to this ball. Then we can add this displacement vector back to our existing location. Now we get the point into this target, and now I'm going to set it as the current location, set actor location. Okay, now I'm going to connect that into the isValid pin, so we have execution flow. Before we talk about this, let me compile and save this. So let me try this over here. So I'm going to hit the simulate button. So then I can hit shoot. You can see it will immediately jump into this ball. Actually, what we did here is not that interesting, and because we don't need to do this in order to achieve that functionality, because we can simply connect it like this and we can simply achieve this functionality without even doing anything like this. What we need is gradually goes toward that target. So that's why we need to have something like this. All right, I'm going to delete this plus because we don't want to do it like this way. Now I'm going to get the timeline component. I'm going to drag this isValid and then I'm search for timeline. Add timeline. You can think this timeline as a for loop, or maybe think like as a keyframe generator. With this, we can create some gradual change from one value to another value. Here, currently we have connected to the play icon. It should be connected to the play from start. Right, now everything is okay here. I'm going to go into the timeline. You can double click on that. Right, I'm going to hit the F plus icon. I'm going to add a float track. So let's say this is progress. I'm going to right click on this graph and add key. Okay, I'm going to set the time to 0 and tap, and values should be 0. So initial position should be 0 and 0. Right. Then I'm going to right click again and add a new key. Here time should be 2 seconds, after 2 seconds, and the value should be 1. Tap. Then I can click these little arrow icons to zoom into these two numbers. Then I'm going to click this first point keyframe, right click, and select the interpolation as auto. So we get a really curve like this. This will give us more smooth curve on times, and it will be really useful when we are doing something like this. Of course, you can change these values and experiment with what you want to do. Everything is ready here. I'm gonna compile, save, and then I'm gonna close this timeline. Right here, and now you can see we have a progress. It will have a value from 0 to 1. Now here's what we're gonna do. Now we have the displacement vector over here. So I'm gonna get the unit vector by normalizing that. So now we have direction, and then I'm going to grab the magnitudes or the size as well using the vector length, and then I'm going to multiply this progress with the vector length. It should be a float to float, something like this. So now I get a gradual change from 0 to this vector length. All right, now we have the direction and a gradual change into that direction. Now I'm going to multiply this direction of the unit vector to float with this gradual change into that direction. Then I'm going to grab this initial actor location and add this our new vector into that. All right, this is our final position based on the time provided by this timeline. Then I'm going to grab this final vector, final position, and connect it to that to this set actor location, and have a look. This set actor location is connected towards the update pin over here of the timeline. Right, I'm going to compile and save this, and then I can simulate this project again. I'm going to select this arrow object. I'm going to hit shoot. You can see we get the expected functionality. All right, let me review this code again. Here we get the target vector's displacement using vector subtraction, and then we grab the vector length and the unit vector, and then we create a timeline to give a number between 0 and 1, and then we multiply that number with the final vector length, so we get the intermediate values. Then we multiply that with the direction, so we get the actual displacement, and after that we add that into our initial actor location, and after that we set the actor's location into this gradual changed position, and that's how we do something like this. Right, give it a try. I think this will be really useful. All right, now it's your time. Try to implement this by yourself. Thank you for taking this mini course on vector basics. I have a complete course on math for Unreal Engine. In there we continue the course that we took up to here. So basically we talk about cross and dot product and how we can use that, and also we talk about different sine, cos, and how they're useful in terms of making games and doing some 3D rotation and so on. And finally we talk about coordinate rotation and how to use them to do very complex rotations in your projects. Okay, check the description below or somewhere on the screen to get to that course, and I hope you like it. All right, see you there. Bye.